Welcome to JCE Connect. We are discussing on pavement design, module 2, McLeod method of flexible pavement design. McLeod conducted plate bearing tests on airfield and highway pavements and developed a design methods where he has taken various sizes of plates and with the test results he has developed an empirical design equation that is T is equal to K log P by S, where T is total thickness of gravel base in centimeters, K is base course constant, capital P on the numerator is gross wheel load in kg, S is total subgrade support in kg for the same contact area, deflection and the number of repetitions of load P which we are considering the numerator, and this S can be calculated as x small p pi a square, where x is the ratio of subgrade support of deflection n for plate bearing test at any diameter to the standard 0.5 cm deflection and 30 cm dia plate. The x value which we will be getting from the second graph on y-axis, and small p contact pressure of plate load test and small a radius of contact of tire pressure, and this k value depends on the loaded area. Apart from that, you can see some simple steps. That is, first we need to calculate the P by A perimeter to area ratio for a given load and a pressure in the plate, and next we need to calculate unit subgrade support reaction corresponding to P by A, and next unit subgrade support, that is S, we need to calculate, and using the formula we can calculate the total thickness. These are the two graphs which we see. First one, the relation between plate diameter and base course constant K. On x-axis we see bearing plate diameters from 0 to 125 centimeters, and on y-axis base course constant K. There is a linear relationship which we find after 25 centimeters of bearing plate diameters. And the second graph shows that is the relationship of subgrade support with perimeter to area ratio. On x-axis we see perimeter area ratio. The values are given above: 0.04, 0.08, 0.12, 0.16, 0.2, 0.21. And on y-axis, that is small x, that is a ratio of subgrade support to the standard subgrade support at 0.5 cm deflection, 30 cm dia plate. And for a highway wheel loading for 10 repetitions, the values are given, and for various dia plates on in between lines we see that is 45 centimeter, 37.5 centimeter, 30 centimeter and 20 centimeter dia plates we can see, and inclined lines what we see is nothing but the deflection for various deflection from 0.125, 0.25, 0.5 like that up to 1.7 centimeters. So let's discuss one simple question paper problem. Here he has asked to design a highway pavement for a wheel load of 4100 kg with a tire pressure of 5 kg per centimeter square by McLeod method. The plate bearing test carried out on a subgrade soil using 30 cm dia plate yielding a pressure of 2.5 kg per centimeter square after 10 repetitions of load at 0.5 cm deflection. He has asked it for 10 marks. So first write the given data. He has given capital P load 4100 kg, small p, that is tire pressure 5 kg per centimeter square, and the plate bearing test details: dia of the plate 30 cm, repetitions 10, small p 2.5 kg per centimeter square at 0.5 deflection delta is given. So first step, as is the radius of contact is not known, so small a is equal to square root of p by pi into small p. So small a is 16.1 centimeter we are getting, that is radius. So we can easily calculate diameter 2 times the radius, that is 32.2 centimeters. In the third step, using the diameter of the plate, we can go for the calculation of base course constant. So for 32.2, here we are getting K value as 90, and perimeter to area ratio P by A is equal to 2 by A, that is nothing but 0.124 value we are getting. For 0.5 centimeter deflection and 10 repetitions, we can calculate X from the second graph. This is 0.5 centimeter third line, 0.5 centimeter deflection, and 0.124 is the P by A value, for which we need to calculate this X on y-axis. So here is the point which coincides, so approximately we are getting one value. So you can calculate S as 2035 kg. You can apply directly the formula T is equal to K log P by S. So we are getting total thickness of base course as 27 centimeters, over which we need to provide 5 centimeter bituminous surface. So very simple steps. You can try this problem, the second, which they asked it for 6 marks, 10 CV 833, that is VTU question paper problem. Thank you.